Let's shatter a huge illusion right out of the gate. We so often think of the internet as this invisible, floating magic, right? Like a cloud of information that just effortlessly beams onto our screens. But the truth? The truth is far more physical, and honestly, a whole lot more fascinating. Today in this explainer, we are going to trace the actual physical journey of internet data. I want you to think of it like this high-tech, cyberpunk digital landscape, where data travels through heavy physical gateways, gets sorted by digital traffic cops, and is literally beamed through the air directly into the devices in your hands. It's this complex, beautifully orchestrated mechanical ballet, and it's happening right inside your walls.
So here is our holographic map for today's journey. We'll be covering 1. The network's door, 2. Data traffic, 3. Expanding wireless range, 4. Digital security and the network card, and finally, 5. Bridges between networks. Let's jump in.
Okay, let's dive right into Section 1, the network's door. We're looking at the modem and the router.
Our journey starts at the exact spot where the outside world hits your building. The very first piece of hardware at this threshold is the modem, which is actually a mashup of the words modulator and demodulator. When you get service from your internet service provider, the data coming through those thick copper cables or fiber lines from the street, it travels as an analog signal, kind of like continuous, rolling waves. But here's the problem. Your phone, your laptop, your smart TV, they don't speak wave. They strictly speak the digital language of ones and zeros. So the modem is your ultimate translator. It captures those analog waves and translates them into a digital format that your devices can actually process. And when you send an email out, it does the exact reverse. Without the modem acting as this crucial translator, the entire internet would literally just stay stuck on your doorstep.
Now the modem successfully gets that digital internet into your home. But there's a catch. It usually only has one single exit port. In a modern home with dozens of smart devices, who manages the chaos? Well, that's where the router steps in. If the modem is your front door, the router is the highly organized digital traffic cop standing right there in the hallway. It takes that single internet line from the modem and creates a local area network, or a LAN. It actually gives every single device in your house its own unique local IP address. By using something called NAT, Network Address Translation, the router ensures that when you tap a YouTube video on your smartphone, that heavy video data routes exactly to your phone and doesn't accidentally start blasting on the television in the living room. It's what prevents massive, frustrating digital traffic jams.
So the crucial point to remember here is how precisely these initial steps flow together in a strict sequence. Step 1, the continuous analog signal arrives from the street. Step 2, the modem translates that wave into a digital stream of ones and zeros. And Step 3, the router catches that digital stream, assigns local IP addresses, and confidently directs the traffic to the right device. Boom, the threshold has been crossed.
Moving right along to Section 2, data traffic. We'll compare the switch and the hub.
So a typical router only has about 4 default ports for wired connections. But what if we need to multiply our wired connections, say for a big office or a massive gaming room? We use a switch. Think of the switch as a smart private courier. It actively memorizes the unique hardware MAC address, basically the digital fingerprint, of every single connected device. So when your computer downloads a file, the switch sends that specific data exclusively down the one cable connected to your computer. It leaves the printer and the TV completely alone. But back in the day, we used a device called a hub. And a hub is just pure chaos. It doesn't look at addresses at all. If it receives a piece of data, it blindly shouts it out to every single device plugged into it, whether they asked for it or not.
To put it perfectly, while a switch works like a private courier, a hub is literally like someone shouting with a megaphone in a public square. Imagine 20 people in a square, all shouting different messages through megaphones at the exact same time. Nobody can understand a thing. That deafening data collision is exactly why hubs brought networks to a crawling pace and why they are completely obsolete today, totally replaced by the sleek, highly efficient, targeted switch.
Let's move into the airspace now with Section 3, expanding wireless range. We're looking at the access point and the repeater.
Since most of our devices today tether to the network wirelessly, think about this for a second. How do you actually stay connected while walking down the endless corridors of a massive hotel or a hospital without your Wi-Fi constantly dropping and reconnecting? Because let's face it, a single standard router is absolutely not pushing a signal through dozens of thick concrete walls.
The brilliant answer to that is the access point, or WAP. You've definitely seen these before. They usually look like little white smoke detectors stuck on the ceilings of large buildings. I want you to think of your network as the plumbing in a building. The router, that's your main heavy-duty water pump.
The access point, it's the digital water sprinkler. It takes the strong wired internet traveling through the Ethernet cables hidden up in the ceiling and just sprays it out into the room as a powerful fresh Wi-Fi signal. It doesn't do any routing. It purely converts a hardwired connection into wireless coverage exactly where you need it most. Now contrast that access point with a range extender or a repeater. This is that little block you plug into a wall socket at home to try and fix the dead zone. Unlike the access point, it doesn't plug into a physical cable. Instead, it grabs the existing Wi-Fi signal out of thin air and essentially shouts it further down the hallway. It's exactly like a person repeating a message they just heard. It's a super cheap, easy fix for home, for sure. But because it has to spend time listening to the signal and then retransmitting it, you actually end up getting a slight drop in internet speed. All right, on to Section 4, Digital Security and the Network Card, the Firewall and the NIC. Now that we've distributed our network all over the place, we really need to shift our focus to perimeter defense. Before data is allowed to just freely roam around your house, it has to get past the firewall. The firewall is your uncompromising digital security guard. It sits directly between your safe, internal network and the wild, totally untrusted outside world. It rapidly inspects every single piece of incoming and outgoing traffic against a really strict set of security rules. If some unauthorized, suspicious request tries to ping your laptop from across the globe, the firewall just silently blocks it. And the best part? A basic hardware firewall is usually built right into your home router, quietly protecting you 24/7 without you even knowing it.
But here's the thing. You can build the most amazing lightning-fast network in the world, but if your device doesn't have an NIC, a network interface card, it is completely deaf and mute. The NIC is the actual physical hardware that gives your device a voice and ears. Whether it's an Ethernet chip soldered right onto your computer's motherboard or a tiny USB Wi-Fi adapter you plug in, that is your NIC. And crucially, every single NIC is manufactured with a permanent, unique MAC address. That's the digital fingerprint that allows the network switches and routers to uniquely identify exactly who is speaking and who is listening.
Finally, let's wrap up with Section 5, Bridges between networks, the bridge and the gateway. So we've successfully built our local fortress, right? But eventually, we need to connect with other network islands out there. Let's look at the network bridge first. A bridge connects two separate network segments that speak the exact same language and makes them act as one single network. A really great real-world example of this is if you have a PC connected to your home Wi-Fi and you run a physical Ethernet cable from that PC to a gaming console that maybe doesn't have Wi-Fi. You can actually create a software bridge right on your PC. It links those two connection types. And just like a real-world bridge, it doesn't let absolutely everything cross. It only passes the necessary traffic across the gap, which prevents a ton of unnecessary congestion on either side. And this brilliantly illustrates the final piece of our puzzle, the gateway. While a bridge connects networks speaking the same language, a gateway acts more like a digital currency exchange or even a passport control checkpoint. It connects two worlds that use entirely different protocols and rules. When data hits a gateway, its entire format gets translated and repackaged so the new network can actually understand it. In fact, that home router we talked about way at the beginning, it is acting as a gateway, taking the language of your private local area network and translating it into the incredibly complex routing protocols required to travel the massive global internet infrastructure. Okay, let's take a quick breath and do a rapid-fire recap to really solidify this high-tech journey we just took. The modem translates those analog waves to digital. The router directs that traffic using local IPs. The switch intelligently multiplies your wired connections. The access point expands your wireless range like a sprinkler, and the firewall stands guard, protecting the entire network. Every single piece of hardware has a hyper-specific, absolutely vital job. It's truly amazing when you step back and realize that this supposedly invisible digital infrastructure is actually a deeply physical system. It's a world of translators, traffic cops, and security guards quietly powering our modern lives. So I want you to take a look around your own space today. Look at those blinking lights in the boxes in your hallway or your office. What mysterious hardware is pulsing in your home right now, working tirelessly to keep you connected to the globe? Keep exploring, keep learning, and thank you so much for joining me for this explainer. See you next time.